What we're going to do in this video is look at the properties of logarithms. Now you may expect that they'll have similar properties to exponents or properties of exponents, right? So we know that we can write equations in logarithmic form and then bring it back to exponential form. So similarly, we'll study these properties and see how they relate back to the properties of exponents. Okay, so product property of logarithms. If we have log base b, where b, u, and v are positive numbers, of u times v, what we'll do is we'll expand it out. And when we expand it out, we will expand as addition, okay? So log base b of u plus log base b of v. So even though multiplication is going on between u and v, when you expand it out, you'll see addition. Think back to properties of exponents. If you had multiplication of x squared times x to the third, we know to add those exponents even though we're multiplying the bases, right? So let's look at quotient property. We know that when we divide working with exponents, our operation is to subtract those exponents. We're going to go ahead and expand something like this, log base b of u divided by v. We're going to subtract log base b as we expand of u minus log base b of v. Okay, so you can see it in expanded form of subtraction. Again, quotient, division. We subtract exponents. We subtract the logs. There's that relationship between the two. And finally, power property. This one's a little bit tricky, but watch carefully. Log base b of u raised to a number. Now we're going to take that number, that exponent right here, we're going to bring it to the front of the log as a coefficient. So if you had a specific, so again, this is your property, okay? But here's a specific example. So if you had log base 2 of 8 being raised to the second power, or third power rather, let's make it specific here, 3. We're going to bring that 3 to the front, and then we'll sit here and be able to evaluate log base 2 of 8. So again, look at the 3, how it moves to the front as a coefficient. All right, so let's look at 3 examples today. 3 unique examples. The first one, using properties of logarithms, we're going to approximate the following. The first one, we want to approximate what the value of log base 5 of 3 divided by 7 will be. Now in the question, they gave us what log base 5 of 3 is approximately equal to and log base 5 of 7. Now what we'll do first is we'll use the quotient property, which allows me to expand this to log base 5 of 3 minus log base 5 of 7. Once you have it in expanded form, you can then substitute the values given in the question. We are told that this entire value here is equal to 0.683. We will subtract 1.209, and our final answer will be negative 0.526. And that is our final answer. And again, once we've expanded using quotient property, we make our substitution based on the values given in the question. Part B is a little bit different. We don't see any operation going on, but what we can do is rewrite 21 as a product of factors. So I'm going to rewrite 21 as 7 times 3. And once I do that, I see that we'll be using the product property here. Okay, so the first one was quotient property. This is product property because the operation going on between 7 and 3 is multiplication. So when we expand it out, we'll have log base 5 of 7 plus log base 5 of 3. And similarly to what we've done in number 1, we'll go ahead and substitute those values of 0.683 plus 1.209, and that equals 1.892. Right? Again, substitute those values. That was equal to this value, and that was equal to that. There we go. All right. Last we have the number 49. Now we can rewrite 49 as 7 times 7, or we can say log base 5 of 7 squared, which is equal to 49. So that's totally up to you if you'd like to write 7 times 7 or 7 squared. I decided to write it as 7 squared so that I could show you how the power property works. We'll take that exponent of 2, bring it to the front as a coefficient, and we'll have log base 5 of 7. This value is equal to 1.209. And then finally, multiplied by 2 will be 2.418. Okay? So these 3 examples specifically were used to approximate the following questions. Okay? So here we go in the next problem. Number 2, we're asked to expand a logarithmic expression. And you can use those properties of logarithms to expand and also to condense, bring it back to one logarithm. So the third example, I'll condense, but in this example, I'll expand. The first thing I notice going on is division. I see multiplication. I see power going on. We'll do one step at a time, only use one of those properties at a time. So I'll use the quotient property to start to expand this out. So log base 2 of 7x to the third minus, there's my quotient property, taking division, expanding it out as subtraction. Log base 2 of y. Next, I'm going to choose to do product property because I see multiplication going on between the 7 and the x to the third, or x cubed. So I'll expand this out as addition. And last, we have the power rule. We're going to take that exponent and bring it to the front as a coefficient. So we'll have log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. Just keep in mind, as you expand that, you've written the 2 as your base for each term. Okay, so that's the final answer, expanded form. Okay, this is considered to be a single logarithm, and this is considered to be expanded form using your properties. Now what we'll do is I'll give you quite the opposite. I'll give you expanded form, and what we're going to do is we're going to condense it. So we'll work backwards. I see I have a coefficient, log, this is a base 10, even though it's not written there. So I'll have 6 plus log 2 squared minus log 3. So I'm using the power rule backwards, bringing it back to an exponent. I see addition going on, so I know those values are going to be multiplied together. And then I see subtraction, so I know there must have been division. So I'll take log 6 times 2 squared, divide by 3, and we can go ahead and simplify that. We have 2 squared, which is 4, and 6 times 4 is 24, and 24 divided by 3 is 8. So our final answer is log base 10 of 8. So again, if you don't see a number there as the base, it's automatically 10, okay? So our final answer is log base 10 of 8 for this problem. So again, we had 3 terms here. We brought it back to a single log, all right? So do your best with the con. Let me know if you have any questions.